All right, welcome back. Okay, so now we're going to talk about two ways we're going to talk about elimination processes, and there's two of them we're going to talk about. One is called the Gaussian elimination, and the other one is called Gauss-Jordan elimination. But before we talk about that, we need to introduce a couple of definitions. The first definition is what we call row echelon form, right? So we want to know when is a matrix in row echelon form. Also, when is a matrix in reduced row echelon form. So a matrix is in row echelon form if it satisfies the following three conditions. One, any row consisting of only zeros in the row are at the bottom of the matrix. Okay. Two, for all other rows, the first non-zero entry is a 1. Okay, we call these entries, these ones, are called leading ones, right? So it's the first non-zero entry of the row, and it's the leading entry, and we want that to be a 1. That's what we call the leading ones. Okay. Now 3 says the leading one in each row is to the right of the leading one in the row immediately above it, right? So let me say that again. The leading one in each row is going to be to the right of the leading one in the row immediately above it. Okay? So if a matrix satisfies these three conditions, then we would say that that matrix is in row echelon form. Now, reduced row echelon form is a matrix that is in row echelon form and it satisfies one more condition. And the one more condition is that each row with a leading entry of a 1 has zeros above that leading 1. So in the same column of the leading 1, all of the entries above it are 0. Okay? So that if a matrix satisfies the 4 conditions, right, the 3 here and then the 1 down here, we would call that matrix in reduced row echelon form. Okay? And so what we're going to do is we'll show you some examples in the videos following, but this is the definition of what we're going to call row echelon form and reduced row echelon form.